And then as far as quizzes go, there's 2 quizzes supposed to happen today in the lab and the pre-lab check. I'll just check that on Wednesday, hopefully, if the campus is open. And I'm not too worried about those quizzes being done like on exact days, because but I'd hope that you'd studied for them as if so you know that material now for today. But if that has to get pushed back a little bit, it's okay. They're obvious quizzes, right? You already have the quiz in the answer. Not like something I feel is precious that I want everybody to take at the same time. Yeah, so we will do the quizzes in person. And I have my outline. Oh, I think my outline doesn't say that, but it will now. I'll adjust it.
I'll start here. So Monday, August 30th. So I saw this organic chem meme. I thought it was pretty funny. So are you hard? Yeah. Show me. Does anybody get it? And so that, I got comments here. Let's see. So this right here is the structure of a tetrahedral structure of sp3 hybridized carbons, we could say. And it's the allotrope of carbon, the diamond allotrope. And diamond is considered like one of the hardest materials, maybe the hardest material on the Mosher's 10-point scale of hardness. I don't know how you say his name, that name. 10 is a diamond rating. That's the hardest material, and then sapphire and rubies are 9, and these guys are. So that's the joke. All right, so we'll do the intro, and then chapter 1, we'll get back into chapter 1. And it's a great idea to click back through these lecture outlines to keep up on things in class. I'll always kind of tell you what's coming up next and give you advice and stuff. So it's a good idea to click back through these, even if you're watching it live. Okay, so past peer Morgan update again. It's Morgan's past peer times are 9 to noon, and linked in Canvas. So if you go to Canvas, you see Morgan's past peer Zoom links. You click on that, and you can find the Zoom link. And then the class Discord that Morgan will be a part of is there too. And I want to encourage you to go to this. So I'll give you 1 point extra credit for your first visit to Morgan's past peer session. So stay like 20 minutes. I mean, don't just check in for 30 seconds and leave, but stay for like 20 minutes or so. Take advantage of that, and then see what it's like. Hopefully you'll like it and you want to stay. If you do that, you'll get an extra credit point. And that's in the assignments in Zoom. I mean, in Canvas, you can click on do that. And so we looked at the step-by-step. This week we're good there. And then the schedule, here I'll take a quick glance at the schedule. So today was the bond line structures in 3D quiz. Let's see. Quizzes. To Wednesday for students. Quizzes and pre-lab check. Okay. All right. And I'll keep the functional group quiz there. So I'll have a lot of quizzes on that Wednesday, but they're all pretty straightforward. Okay. Oh, is that it? And then after this week, next week we have a Monday off, so I won't lecture on Monday. It's Labor Day. Add drop deadline, refund deadline is that day as well. And I'm going to make up this basic skills workshop. I'll give you that later. I want to look through it and update it. Haven't had time yet. And oh, and then on Tuesday, I'll normally I would say if it wasn't pandemic, I'd say Monday, Wednesday lab students, you can come to the Tuesday lab section to work on this basic skills workshop with the other students. But now I don't know if I'm supposed to have more than a lot of people in lab, but I'll set up a Zoom on my computer and you can attend that way. Yep, and then a curved arrow mechanism quiz, IR, NMR data quiz coming up, PK quiz, exam 1. So, okay. now. So come to lab today and, oh, what fun. It's supposed to be. What happened? Okay, let's go here. Let's escape. Finally, okay. Come to lab on Monday, Tuesday. With the Green Pass course, you know, your phone thing. And then spectroscopy introduction, pre-lab. So of course, this is Tuesday, Wednesday now, but bond line structures and 3D skills, because that quiz, counting secret hydrogens and formal charge, computing device with internet. So if you, this last week, it went pretty well. A lot of people, like most people had it. Oh, I forgot. I was going to look into maybe trying to get us a hotspots for lab, because it seems like our Wi-Fi is pretty weak in lab. And then goggles. So please bring goggles. We're going to check into our lockers. So once you bring your goggles, you can store them in your locker so you won't ever forget them. And UVEX goggles are good, these ones. And I hear someone's got their not unmuted. Let me see. Is it possible for me to mute everyone? Or did it just get taken care of? Feels like it did. Okay. Okay, back at it. There we go. And then more extra credit. So come to my office hour. Tuesdays and Thursdays, I have office hour 9 to 10. And stay like 20+ minutes, and you can get on the Jamboard and start working some problems with us, and I'll give you 1 point extra credit. I think, yeah, that was it. All right, so then last week I had about half the students watch live lectures, about 20 students, and I have about that many now today too. Can you guys see how many number?
That's 24.
24, nice. Okay, so I got like 24. Yeah, 23. Thank you. And then so I had about 20, which is pretty good, but I want more. And I had about 24 views on my YouTube channel for each lecture, because I had the 2 lectures up on YouTube. Oh, but you know, some people might have watched it via the Canvas video too. Well, but then when I looked at the lecture details, it said like the average watch time of the lecture videos was like 10 minutes per lecture, but they're like a 90-minute lecture. So that was a little bit like, ooh, okay. So I just want to encourage those of you who are those of you who are live now, you're live, but those of you who watch this after, yeah, don't fall behind in lecture. And the best way to not fall behind is to come to it live if you can. All right, so even more extra credit. So come to my live Zoom lectures and let me know about it, and I'll give you an extra credit point for up to 5 extra credit points. So you'll just go to the assignment and say, oh, I came, for those of you live now, you'll go in there and say, I came today, and I'll give you an extra credit point. And then the next lecture you come to, I came this date, and then I'll do it until 5. And if you cannot attend any of my extra credit activities I provide you, it's fine. Extra credit can only help your grade. It can't hurt your grade. So I don't want anybody to feel like, oh, I work full time and I can't do all this extra credit stuff, and all these other people, it's a disadvantage because they can. Now, I make it so it's not a disadvantage. What I do is the end of the semester, I assign grades by ranking the total points of everybody in the class. And in that total points ranking, I have extra credit. So with extra credit, I have, the top student, the second, third, fourth, and then I go down and I'll cut it off at like 90% or lower. I never go up. I never say like, oh, you have to have over 92% to get an A. So if you have a 90% or above, you have an A for sure. And I may go down to 89 or 88. I look at those numbers at the end of the year. I don't do a curve, because a curve actually that's results in like, 94 and above can only be the A, second, a true curve. So what I'm going to do is I cut it off there, and then I assign the grades A, B, C, D to the ranking with extra credit. Then I subtract out all the extra credit points, and I get a total points without extra credit, and I rank those people. And no grades can go up after this second ranking. or no grades can go down, they can only go up. So what happens is occasionally you'll see a student who was a B student with extra credit involved because they didn't do a lot of extra credit. Some students were ahead of them just due to their extra credit. And then when I re-rank without extra credit, that B student now has higher natural points total without any extra credit than an A student. And what I do is I'll just give that B student with extra credit an A, because they earned more points than the homework, exams, and all that than the extra credit person. So the extra credit person helped them. So it can only help you, it can't hurt you. So if you have more non-extra credit points than other students that has a higher grade than you, then your grade goes up. So encourage your friends to do extra credit if you could help your grade go up. So. All right, and then homework assignment due dates. This is always an issue with me because my lectures aren't like set, like I don't have a set like amount of lectures it takes me to get through chapter 1. I'm more free flowing, so some years it takes me 3 lectures to get through chapter 1, sometimes it takes 4, you know. So after I finish covering material in a particular homework assignment covers, then I set the homework due date. So I normally set the initial due date for like 4 days or so after I finish covering the material. So let's say I finished homework chapter 1 today, which I won't, but if I did, then I would say, okay, the first homework assignment, which is only chapter 1, is going to be due in about 4 days from now. But I have an asterisk by the due date because remember, I say you can be 4 days late of the normal first due date to get you without any points lost. And they'll be in all these due dates will be in that due date sheet. Okay, so starting homework early is a good idea though, because we'll have covered material, especially after today, have covered a lot of homework or chapter 1 material. So if you look into the homework assignment, you're like, oh, I can do these problems. So that's good to get going. And I'll give you full credit for your homework if you make effort on all the problems. So I don't go through and grade it like an exam, make sure every answer is right. I just, I see that, oh, they're trying, they're learning. That's good. But when you say skip problems 10 to 15 and then go, then you lose points because you're not taking the time to try them. And the homework problems are mostly old exam questions I wrote. So they're a great way to get familiar with my type of exams, and my type of style of questions. And yeah, initial due dates, so you can turn things in late. So there's the due dates file I was telling you about. And there was something else. Oh, the exam. Remind me to put keys in this. I do have a link to like homework keys. I have some keys for you to help you out. So remember to bring goggles today and tomorrow. Not today, but tomorrow and Wednesday. So these UVEX ones are good. If you got those, you can get those. All right, and then before I do that, actually, let me I just thought of something. And I know I've thrown out a lot of like just how I run the class this first couple of weeks, but you'll get the hang of it. And if you're clicking through these outlines each week, you're going to be fine. It'll keep you going. So what do we call this? The keys. I think I have it linked in this one, the top. So I have, I'll just copy this way, keys link. All right, so I'll be putting answer keys here and let's go check it out. I'll show you what I mean. So far I have the spectroscopy quiz key here. So that's a quiz you're gonna take later, but it's one of those quizzes where you have the quiz beforehand and the key beforehand. So you study and practice it, and then you come in the lab and kill it. Same with the pKa and acid-base quiz. And then homework A, I have a quiz key. It says partial key because I've changed up homework A. I've added to it, changed things around a little bit, but this was last year's version of the homework, which was pretty close. So if you're going through this first homework and you're like, oh, I want to check my answers, or you're not sure how to do something, you can check the key out here. I think I don't have, mostly what's missing from this is I've added Google slide animations to the homework. And those Google slide animations actually have their own keys. So you pretty much got a full key here. Yeah, some of it I wrote quick up on a napkin at Starbucks when you're allowed to sit there. I think you're allowed to sit at Starbucks again. Maybe not for smoke though. All right, so then homework B, C, D key. So we have some keys there to help you out. And okay, so I was gonna start back. I was gonna start off with our chapter outcomes, which are linked here. Where that outcome? Yeah. So we're still on. We finished up outcome 1 of chapter 1, and then we were on the functional groups. That's what we left off with last time. So I'm going to go through some of that. Before I start that, though, any questions?
I have a question.
Yeah.
I know you can't tell the future, but do you think we're going to be able to come to school tomorrow?
You know, one thing, if you have an iPhone, if you go into their weather app, they do have, if you look at the AQI, if you scroll down, they have this breezometer link you can click on, and it will predict for a few hours in the future. So it does show right now our AQI is at 177, and it shows at noon it might be down to, let me move. It shows it dipping and then rising, so I only have until 4 o'clock predicted. So I don't know, I hope it opens. I hope so. Yeah. I'm just gonna keep planning for it to open and then deal with it when it doesn't.
What you can also do is like look up like wind patterns and just see where the fires are and like where the wind will push the smoke.
Yeah, that's true. And I did look up this one too. If you want to look at this website, it's pretty cool. It seems like it's showing. You can see it's interesting to see that the monitors, and there's the wind pattern,
cool.
And then so if we look at like Rockland, you can see Rockland, it's got the different monitors throughout Rockland. And I guess what we see for Rockland is an average of those. They all look pretty close. So we will see. All right, so let me get going again. If you could, everybody mute real quick. Okay, thank you. All right.
I have
and
one
then,
more question. I'm sorry.
Sure, that's okay.
I remember you went over the definition of organic molecules one of the times. Could you repeat that definition from the chapter outcomes?
Yeah, it's easy. So organic molecules are molecules that are carbon-based, that have a carbon skeleton to them.
Okay.
So these linear alkanes that we're going to memorize the names of, they're all organic because, as you know now, in the bond line structure, the end of a line is a carbon, and a bend in a line is a carbon. So ends and bends. So there's a carbon. So you can see this is a carbon skeleton that, if I go over to this next page too, you can see these are all organic molecules because they have that carbon skeleton, and then off of the skeleton they have other atoms. Like this is acetone. It has 3 carbons, and then it has a double bonded oxygen carbonyl off of that main chain. So that's the definition of organic molecule, okay. Carbon based.
Thank you.
All right, so let's see if we can remember these. Boom. We'll do a quick review on this right here. So I'll bring up my chat. Let's use the chat. See if we can. There we go. Boom. Drawing utensils out. Well, you could just say it verbally now. Hexane. How many carbons does hexane have?
6.
6.
Yep. 6 is right. Good. There it is. I've got 1, 2, 3, 4, 5, 6. Great. About propane. Like our propane barbecue tanks.
3.
Yeah, good. I see a lot of 3s. Yep. 1, 2, 3. We got it. What about pentane? Sounds like pentagon. 5. Good. Good answer. This is actually, when it's drawn this way, it's W-ane. If you draw it upside down, it's M-ane. Just kidding. Looks like a W, right? 1, 2, 3, 4, 5. All right, and then nonane. 9. Good. Yeah, sounds like 9, huh? So let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Got it. What about decane? Yeah, decade, huh? Easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. And then heptane. That one's maybe the trickiest, but by process elimination, hopefully you can get that one is 7. 1, 2, 3, 4, 5, 6, 7. Good. I'm getting a lot of good responses on the chat. Thank you. And then ethane. 2. That's right. 1, 2. And then octane. That's another easy one, huh? 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then butane. My daddy says butane is a bastard gas. Yeah, 4. Good job. 1, 2, 3, 4. And methane, made by farting and burping cows. And also methane's made by trash in landfills. The trash that's on top of the landfill, that decomposes more completely to carbon dioxide. But underneath, the trash can decompose to methane, which isn't good because methane is 20 times stronger greenhouse gas than carbon dioxide. But if we know this now, so I think it like the landfills, they like turn the trash and stuff and try to do things to help with that. So methane. Okay, so now I'm going to go through our functional groups we need to memorize. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15 of them there, right? But before I click through them with you, like we did the last thing, I want to talk a little bit about them. Let me go to our Jamboard for today. One of the main things we want to talk about is this sub-functional group of carbonyl. I talked about this more in some of the lab sections and not some of the others. So some of you, if you're in the lab section where I went over this more greatly, you'll be like, okay, I already know this, hopefully. But those of you who your lab might not have talked about it, so here you go. James asked, is it in the chat, does it matter how we draw the alkanes? We're actually going to go into that later. So let me give you an example. So good question, James. Okay, I'm on my Jamboard here. So if I draw like a butane like this, that's the same as if I draw it like that. And it's the same molecule, but a different conformation if I draw it like that. And we're going to talk more about this in chapter 3, 2, 3, 3, 2. It's chapter 2. We'll talk about how like some of your passwords in the data link. So sorry, I got a message on my iPad. So this right here, this is higher energy than this because these two methyls are closer to each other. We'll go into that in chapter 2. Okay, so let's talk about a carbonyl. A carbonyl is a sub-functional group. It's a part of other functional groups. And we'll see it a lot. Yeah. Okay, so let's look at what it looks like. A carbonyl is a carbon-oxygen double bond. Just like that. It's different. It's similar but different than an alkene. An alkene is a carbon-carbon double bond. But when you have an oxygen, not a carbon there, now it's a carbonyl. So the carbonyl could have. So that's just your carbonyl right there. Okay, so a carbonyl can have 2 things attached to it. 1, 2. And depending on what you have here will determine what functional group it is. So if, for example, I have a carbonyl, and another carbon, does anyone know what that functional group is called?
Ketone.
Yeah, good job. I see it typed up. That's a ketone. So we just have to remember that. And we're going to be seeing it so often that you'll have it down. So that's your ketone. And now let's try another one. Let's go. I have my carbonyl. And then if I have a carbon on one side and a hydrogen on the other, what's that now? You could type it in. before I say it aloud. Oh, yeah, Cosey's got it. Good job. Aldehyde. Oh, sorry, my handwriting. Yeah, when you have that one hydrogen there, the hydrogen is attached to what we call the carbonyl carbon, then it's an aldehyde. Good. And then if I have a carbon, carbonyl, then an oxygen with a hydrogen, what's that? It's acidic, relatively acidic. Yeah, carboxylic acid. There we go. And then if I have a carbonyl, very similar to this, but it has, instead of an oxygen to a hydrogen, it has an oxygen to another carbon. What do we get then? This one, they can smell nice. A lot of flowers use these functional groups to have a nice fragrance to attract pollinators. So yeah, an ester. Nice. Okay, so wait, do I have more of these? Yeah, I guess so. Yeah, let me do this one next. Actually, before I do this, I want to do this. So I want to make sure we understand this too. If I have carbon, say, and I have no carbonyl here, what's this one called now? Yep, alcohol. So having that carbonyl changes the molecule a lot. It makes this, when you have the carbonyl oxygen here, it makes this a much stronger acid. So that's why it's called carboxylic acid, where the alcohol is a much weaker acid, no carbonyl there. And then the same thing goes here. If I take away that carbonyl for the ester, you know what we call this one? So it has a carbon on ether side. That's an ether. No carbonyl. No carbonyl here and no carbonyl there. It just has carbons though. Okay, so this is an ether, and I like to remember it by thinking has an ether on ether, has a carbon, sorry. Instead of either side of oxygen. Okay. All right, and then the carboxylic acid has a conjugate base. So if we deprotonate this carboxylic acid, get this conjugate base. Does anybody know what that's called? Yes, carboxylate. We'll talk about carboxylic acids and carboxylates a lot in lab. Good. And then now a couple more I'll mention and then we'll practice. The amines and the ammoniums, they're similar and students can mix them up at first, but we'll got to be careful about that. So if you have a nitrogen that has a carbon or a hydrogen off of it, say I have I'll just keep it. I'll go like this first. And then I'll put a hydrogen there too. Okay, so if I have a nitrogen like this, it has a nitrogen with three things attached to it, 3 single bonds, and a lone pair. Is this going to be an amine or is it going to be an ammonium? That's the amine. And then if you protonate that, so it no longer has a lone pair, just has the formal charge of +1 instead of a lone pair, it's now an ammonium. It's named after ammonium, I mean. This is ammonium, right? The parent. So when you see the amine, think 3 single bonds, 1 lone pair. Of electrons. Okay. And then if you see for ammonium, you think positive formal charge and no lone pair. Okay. I think that covers it for us. Oh yeah, I guess amine, amides. Yeah, one more thing. Also, if you take your amine, say this one here, and you throw a carbonyl on it, you add the carbonyl there, it's no longer an amine, now it's an, anybody? Amide, yep. Oh, I was typing it into the text chat. Yeah, now it's an amide. So those carbonyls are kind of key to everything, huh? They show up in most of our functional groups I'm having us memorize. Yeah, and then for this one, the here, I'll just start clicking through. The other ones are more straightforward. They just take a little practice. And I have practice with these. So if you click through the animations, you'll get it. All right, and now, so let's start going through these. This first one, upper left, I believe that's the first one I've animated. What would I call that? What functional group is this? This butane is a bastard gas and it's an alkyne. Alkane. Why did I say alkyne? Whew. Alkane, yes. All right, what about this next one? It has a double bond in it. Good, alkene. And then the triple bond is actually, Santos is asking about alkyl. Alkanes are called alkyl as well, alkane or alkyl, A-L-K-Y-L. And then alkenes are known as alkenes or vinyl, like something off an alkenes, vinyl. These are other terms that are used. And now this next one here, what's this triple bond one called? Alkyne, good. And then when I have a 6-membered ring, this is a real special one. You have a 6-membered ring and it alternates between double, single, double, single, double like that. It's a particular important one because it's very stable, this molecule, and it's found in a lot of molecules, important molecules in our bodies and in plants and animals. This is called, this particular molecule is a benzene ring, it's benzene, or it's also referred to as a phenyl ring or an aromatic ring. It's got a lot of names, but we'll spend actually chapter 15 and 16 talking about this guy. All right, next up, what kind of functional group is this? Alcohol, right? There we go. And then down here, okay, I got a nitrogen with 3 single bonds and a lone pair. Is that the amine or the ammonia? That's the amine. And then now I've got the nitrogen 4 bonds, no lone pair, plus charge. That's the ammonium. And sounds like a word that ends in sounds like a metal, right? Metal is usually positive charge, so ammonium. All right, what about this oxygen with the carbon on either side of it? Ether. And now this one is a sub-functional group. This one's going to be a part of all these other functional groups. So what do we refer to that one as? That's the carbonyl. And then if you have a carbon on either side of the, on both sides, say, of the carbonyl, it is a ketone. This one's acetone in nail polish remover and cleaning solvent in the lab. And then here we've got a carbon on one side and a hydrogen on the other. What's that one? Aldehyde. Yep. And then we have a carbonyl with a nitrogen with 3 bonds and a lone pair. So it's kind of related to the amine, but we throw that carbonyl on there. So now it's an amide. Then kind of related to the ester, I have a oxygen with carbons on either side, but it also has a carbonyl. So this one's a ester. And now almost like the ester, but instead of carbon off of the oxygen, I have a hydrogen. So this one's the carboxylic acid. And finally, if I deprotonate that carboxylic acid, I get the conjugate base, and that's a carboxylate. And when you have 8 on a word, it sounds negative, right? Kind of like the em sounds positive, carboxylate negative. All right, and then I have it opposite here. I'm gonna go real fast. Here's, I ask you to draw an aldehyde. It doesn't have to be the exact same one, but like, it could be that one, which we had before, or this one, or that one. See how these are all aldehydes because they have carbonyl, carbon, hydrogen. All right, and then an amide could be, boom, amide, 3 bonds to nitrogen and the carbonyl. The ester, 3 bonds, or it's got carbon on either side, but a carbonyl too. Carboxylic acid. Actually, I'm gonna go through this fast because I think this is stuff you can practice on your own. All right, so this is all part, I took this out of the Google slide animation for this. Oh, and then the sample quiz. I wanna glance at this really quick because there's tricky ones in this that I wanna teach you the tricks so you don't get tricked. So for instance, this is a good one. Actually, so we got that guy there. So it's easy to get tricked with things like this one right here on the right, this guy right here. So what do we got here? Is this a carboxylic acid? It's got a carbonyl and an OH. What do you guess? Is that a carboxylic acid? It's not a carboxylic acid. The carboxylic acid has to have the carbonyl at a certain position. So this guy is the following. I've got a carbonyl with a carbon and a carbon. So this is a ketone, not a carboxylic acid. So a carboxylic acid needs a carbon, carbonyl, and then an oxygen right directly attached to the carbonyl carbon, where this OH is not directly attached to the carbonyl carbon. So we have 2 functional groups that are just super close to each other here. So that's a ketone. And then this guy is considered an alcohol. All right, and then there's a bunch more here. We've got alkene. I'll just kind of, the answer key is already up for all this, but we'll just quick review. We've got a ketone again. Oh, what's this one here? Is this an ester?
No, I think that little one is a ketone again, wouldn't it be?
Yep.
And then there's
ketone. And then this one is what? It's got a carbon on ether side. Ether. So I'll let you continue with this, keep practicing on those. And it is kind of like a trick question, this one and this one, but they're important because like this ketone and alcohol have very different reactivity than a carboxylic acid. They're just completely different. So you need to know the difference and we'll get good at it. And I've already showed you my trick, so you're ready to go for the quiz. Oh yeah, and then there was another thing about this. Did you see the video game? I think I showed you last time in lecture, right? The formal chart of the functional groups video game. That seemed kind of fun. So let me show you. Should go to the functional groups quiz. So as you click through this, you'll learn all this stuff real well. And then at the end, I mentioned this. Now that's the memorization helper. This is the quiz. This is kind of cool, these purposeful games. You want to try it out. So when you play it, you start off and it asks you to find the carboxylic acid. Oh, here it is. Click on it. Find the alkyne, the triple bond. Where's the triple bond? Where's the triple bond? There it is. An ether, carbon on either side of the oxygen. Ketone. Boom, carbon on either side of the carbonyl. Alkane. Acid halide. So we didn't learn that one, but that's a new one if you want to learn it. Alkene. Aromatics. That's aromatic is benzene ring, phenyl ring. Alcohol. Uh-oh. Where's my alcohol? Oh, there it is. Amide. Boom. Thiol. That's a new one for us, but it's like an alcohol, but with a sulfur. And then aldehyde, we know that one. Ester. There we go. Amine. Boom. It doesn't show the lone pair on the amine. I don't like that, but it doesn't show any lone pairs, which I don't like, but that's okay. Alkyl halide. This is one we didn't learn, but boom, what I get? 100% right. Today's rank 378th, not good. Just slow and old. That's okay. So good. So I think we're done with functional groups. Now it's just up to you to get ready for this quiz. Piece of cake, huh? Any questions about that? Okay. And I have 3 files to help you out with that. The functional groups explained, a memorization helper, and then a sample quiz. All right. Okay, nomenclature. We did it. Curved arrows. All right, we're at curved arrows now. I like curved arrows. So actually, let me see what time it is too. We'll go a few more minutes. So curved arrows is another big thing for us. So we've learned about bond line structures. That's pretty fundamental for what we're going to do. And now curved arrows is the next really fundamental thing we need to know. We'll have a quiz on this one too in week 3, not this week, but next week. So I'm just going to do the start of this Google slide animation. You'll go through the whole thing. I went with the Dr. Seuss theme on this one. So curved arrows. Oh, the places you'll go by Dr. Seuss. No, by Dr. Springsteel. And we'll use many. Oh no, I didn't change the title too. Oh, the places you'll go by Dr. Seuss. And this is, oh, the arrows you'll throw by Dr. Springsteel. All right, so we're going to use many arrows this year, some thick, some narrow. Some you've already seen. I'm sure others your ignorance of will cure. So this is an equilibrium arrow. I think you guys have seen that a lot. This is just an overall reaction arrow. This, you've maybe seen this, but not in the way that I'm in it. This is called a reflux arrow. This refers to heating a reaction to boiling and then having its fumes be condensed and dripped back into the reaction so they're not lost. We'll go into that more later. And then this is a dipole arrow. I spent a lot of the end of the summer working on a Google slide animation for this. And then the retro arrows, these are going to be retrosynthesis arrows. You don't know what these are yet, but they are coming. Retro is coming. And then these ones, you guys know what this one is, right? Anyone? What kind of arrow? Double-headed arrow. What do we use that for? Resonance arrows for resonance structures. And then now introducing curved arrows, the star of the show, ones you'll deeply get to know. So curved arrows look like this, a full-headed arrow, or this is a full head of the arrow, or half-headed arrow. Sounds like half of the head of the arrow. So I'll explain what all that means. And I think I do a good job explaining it here, but I'll let you read through it. I'll give you another way. Actually, I'm going to do that part really quick too. So these curved arrows are meant to represent electron motion. So a full-headed arrow represents a pair of electrons, so those 2 pairs of electrons reaching out to make a bond to another atom. And then a half-headed arrow is for when you have an atom with unpaired electrons, radical electrons. So it makes sense, huh? The full head of the arrows, 2 electrons, only half head, only 1 electron. So we'll be spending a lot of time with these. Let's practice some. Back to my Jamboard here. The most important reaction we're going to learn is just straight acid-base chemistry. And I hope when you're going to get to the point where you get really good at this and you're going to think, oh, wow, this makes understanding acid-base chemistry much easier. And to help you at the start, and for a lot of the year, I'm going to use colors to represent the arrows that are moving and changing. So here we go. I have a molecule here. Does anybody know the name of this molecule? OH minus, what's that called? Hydroxide, yep. Yeah, we got hydroxide, our most common base. And then I'm gonna draw up, I'm gonna have it react with, say, ammonia and ammonium. Let's go H and H, do this, something like that. And I'm going to make this bond to the nitrogen blue so we can really see what's going on. This is ammonium. And this is ammonium. Okay, it's got the nitrogen with 4 bonds and a plus charge. All right, so how do we do curved arrow mechanism? This is what we do. You start on the pair of electrons that are reacting and you touch, you got to touch the electrons, and then you go over and touch the atom that it's going to reach out to. So think of this as, think of the red pair of electrons is like a rope reaching out to grab. Or you can think of it as like a lasso. So this red pair of electrons is going to reach out, grab that hydrogen's nucleus. And then while it does this, the blue pair of electrons, that rope breaks and it becomes a lone pair on the nitrogen. And there we go. So now to draw the products of this reaction is I can use equilibrium arrows, but it's like very product favored. So I'll make it equilibrium arrows, but like stronger to the product side. And what I make in this reaction is the following. Water and amine. So you notice the blue bond that we started with. Blue bond at the start is now a lone pair of electrons on the nitrogen. So the 2 electrons that were in this bond are now a lone pair. And then also the red pair of electrons at the start is now a bond in water. So these 2 electrons now, they reached out and they made a bond to that hydrogen. And that's what they are now. Does that make sense? And then Santos was asking about the colors of the bonds I chose, if like red is new bonds, blue is breaking bonds. In this case, yes, but not always. I could have chosen this red pair to be purple or brown. It was kind of random. I tend to always make the bases. This is a base hydroxide red and then acids blue, just for style, but doesn't matter what colors you choose really. Okay, so now I'm gonna actually pause and then we're gonna come back and we're gonna do a lot more practice with this. We'll take a 10-minute break. Before I go on that break, do you guys have any questions? Any more questions? Oh, I said not a bond. Thank you for that correction, Annalise. Annalise, sorry. The red pair of electrons at the start is now, not now a bond in water. There we go. Thanks.
A couple things. Here, can I move this to the new panel? Yeah, I can. So I fixed the. I didn't fix. This is something I added. So today, those of you in Monday, Wednesday lab, we can't go meet in person today, but we'll still meet via Zoom. And in ConferZoom, within where you found this lecture, I have a lab meeting due to smoke link. So we'll meet there and we'll go over some good stuff. And then the other thing is I corrected this error, the finding errors error. And I hear Caitlin's saying it was Katie found it. So yeah, I'll give you both the point for finding that. And then Uvia, she found another error. She messaged me. Oh, you know, while I'm thinking of it, those of you who are here, I'm not a huge fan of the in this message app within Canvas. I like our regular email better. So if you, it's no big deal if you message me on the other one, but if you have like a question, if you want to email me, I like the school email much better. It's easier to copy and paste things into there and make attachments where, yeah, so that's it. Back to curved arrows. So curved arrows are very helpful. They make organic chemistry so much better to learn, so much easier to learn and more enjoyable, because you'll see patterns, and instead of just memorizing a lot of reactions, you'll look at two reactions and say, well, how would they react? Oh, that base is gonna, you know, reach out its lone pair and deprotonate this guy and break that bond. So we're gonna use curved arrow mechanisms throughout the whole year, and you'll get better and better at them. And since I started doing this whole color-coded curved arrow thing, it's really helped us improve, help my students learn it quicker and more deeply. I do have some really nice ones I want to show you. Let's see. Just to give you a little idea of where we're headed. So in our animations for the class. So these animations, don't get overwhelmed for it. This animations link is meant to be just like all my animations will be listed here. So as you're going through the semester, you might think, oh, I want to look back at the bond line structures in 3D animation. You can come here to look for it. You don't necessarily have to come to this place to navigate the class. I think the better way to navigate the class is through the organic chem step-by-step, but this is just like kind of a catch-all for all my animations. And let me show you some good ones. Let's look. I like the epoxide one. Does anybody like Game of Thrones? That one. Ether, epoxides. This is rainbow. Oh yeah, this one. So you can see, I'll just show you a little bit of this to get you a preview of how good you're going to become at these curved arrow mechanisms. So this one's a Game of Thrones themed one. Oh, spoiler alert, there might be some spoilers in this. So, oh, the things we'll do for the love of making bonds. So here we have an alkene, right? Got a double bonded carbon. This D stands for deuterium. That's an isotope of hydrogen atoms. Hydrogen's most abundant isotope has one proton, no neutrons. If a hydrogen has a proton, still a hydrogen, just one proton, and a neutron, now it's deuterium. We'll talk more about that. And then this is a metachloral peroxybenzoic acid, of course. you wouldn't, it's a big one for now, but we'll get to it later. And it can be used to turn alkenes into something we call epoxides. This is an epoxide. And epoxide is a cyclic what functional group? Can anybody tell me what functional group we got there? It's got an oxygen with a carbon on either side of it. It's an ether. So an epoxide is a cyclic ether. So here in this reaction, your alkene turns into epoxide, and then your peroxy acid, is what we call this, turns into a carboxylic acid that we're used to. And you get these years. We'll learn what racemic yield means in the future. But here we go. See how I'm color coding this pi bond? And I'm color coding there's a purple bond between the OH here, the yellow bond between the two oxygens, and one of the carbonyl bonds is green. And then I'm also going to add in something I found really helpful, these like a hinge here. So it's like a hinge of a door. So this pi bond's going to swing out on that hinge. And then a few years back, I had a student, Katie Roach, and I asked her, do you like the hinge? And she's like, it's all right. So as a joke, I named it after her. So now it's the Roach hinge. So Jamie's like, is that Bravasi gold? So anyways, the reactive peroxy bond is what drives this. So here we go. This red pi bond is going to swing out and make a bond to the oxygen, hinging on that gold Roach hinge. And while it does that, the yellow bond is going to break, and it's going to swing on the oxygen here to become a pi bond to that carbonyl carbon. And then the green bond of the carbonyl is going to swing up, hinging on the oxygen to grab the hydrogen. And then the purple bond is going to reach out and make a bond to the carbon where this red one is swung away from. And you wind up making your oxides. And it can attack this metachloral peroxybenzoic acid. It can attack from our side of the screen or the back side. So you can get the wedge or the dash. And so just real quick on the colors, see how I said the red would hinge on the gold. So the red is going to make a bond right there that it's either going to be wedge or dash. And then the purple is swinging over, hinging on the oxygen to make that purple bond. And then the yellow, you'll see it's swaying over here. So it's right there. And the green hinging on the upper oxygen of the carbonyl, it swings up. So you can see colors help you see it there. And then we go on to like learn more like, oh, we got to, these react with under acidic or basic conditions, blah, blah, blah. We'll get there later. That's not till chapter, when is that? Chapter what? Chapter 9. So we're still in chapter 1. But I wanted to show you like these curved arrow mechanisms are really going to help us. So let's continue on. Let's do some more. I'm 7. Okay, let's do another acid base. Those are big ones for us. So I'll go with, this would be like an actually, yeah, I'll choose our function groups. Here we go. What happened? What happened? Oh, were you seeing what I was drawing? Okay, good. My app had kicked me out for some reason. I'll get right back in here. Okay, so I've got this. Oh, what the heck? I don't know what's going on. I think I maybe have to turn my iPad this way. I think my palm is, oh man, technology. Lock the screen, unlock the screen. Okay, come on. We can do this. There we go. Okay, back at it. I'm going to make a lone pair of electrons red on this guy. And then I'll have it react with HCl. Okay, so can you guys tell me anything about these two molecules? What do you know about it? Can you tell me anything about the one with the negative charge here? What kind of functional group is it?
Oxalate.
Yeah. This is a carboxylate. And this particular one is called acetate. You may have heard of that in general chem, CH3 CO2 minus. Does that sound familiar? I should write it. Did you have to memorize some common polyatomic ions, right? You might have saw it as CH3CO2 minus or C2H3O2 minus. Does that ring a bell at all? Acetate. Okay, so, and then what about this other one? What is this one here?
A strong acid.
It's a strong acid, yep. And it's this particular acid, what's HCl called?
Hydrochloric acid.
Yeah. Hydrochloric. Strong acid. Okay. And then they will react in the following manner. The lone pair of the base, the carboxylate, is going to reach out and deprotonate the acid. So I'll use red there, and you'll notice I'm going to try to be very good. I want us to always be touching. And I don't mean it in a creepy way. I mean the arrow starts touching, lone pair of electrons in this case. Then the head of the arrow touches the atom it's reacting with. And I'm being really picky about this because I've found through the years, if I am, you understand this a lot better, you learn it faster, everything's good. So no social distancing for the arrows, that's right. We're touching. Now, I'm going to do the same thing. I'm still touching here. I'm going to go touch the blue bond, which is going to break and go over to the chlorine. Boom, there we go. So now hopefully you're starting to see the products of this. This is going to be a very product favorite reaction too. Here we go. I'm going to have a new bond to the oxygen. What color should I make the bond between this hydrogen and this oxygen? Good, I see it in the chat, red. Nice. And then the hydrochloric acid is now just what? What do we call it? And what do I need to add to this chlorine? I need to add a lone pair. And it's got to be what color? Jackson got it. Anybody else? Ryan got it? But it's not chlorate, it's chloride. Close though. Okay, yeah. So I've got chloride. And let me make that guy blue. That looks better. Huh? Let's make this one blue too. All right. And then our carboxylate is now what functional group? I got a question about the formal charge of the chloride, but let me first just finish this thought here. So what kind of functional group is this now? It was a carboxylate. Now it's a and this particular carboxylic acid, probably heard of, is the most famous one. This is acetic acid. This is what's in vinegar. Good. And then the chloride, yeah, it was a question about the formal charge of chloride. So chlorine, its formal charge is such. Group 7 minus 0 bonds, minus 8 electrons. So it's got a -1 formal charge. It does have an octet, but having an octet doesn't mean you have no formal charge. No worries. And then, okay. Good on that one. Let's do a more complicated one. Let me come up with a good one we're going to learn in the future. We'll go the old Diels-Alder reaction. That's a nice one. So this is a reaction made up by a couple guys, Diels and Alder. And it's an important one because it makes 6-membered rings, and 6-membered rings are found a lot in nature. So this is a more complicated one. And in this one, I'm going to use my roach hinge as well. Okay, here we go. So I'll make the roach hinge yellow. Imagine if I put a hinge right here on that top carbon of that alkene. This is an alkene, right? And then it's going to react with the what's called a diene to the left. It has 2 alkenes. And the way it's going to react, it's going to swing open like so. Oh, wrong color. The red pi bond of this is going to swing out like that. And it's going to make a bond to that top carbon of the diene. And then that diene is going to have a hinge here. And its green pair of electrons in the pi bond is going to swing down here to make a bond, a double bond in the middle. And then we'll have another hinge here. And this blue one's going to swing out to there. Pretty crazy, a lot going on, huh? And so our product is going to be a 6-membered ring. And let me actually go ahead and number this for us. I've used up all my colors. I'll make it red, I guess. Let's go with, let's call this 1, 2, 3, 4, 5, 6. So this would be carbon 1, 2, 3, 4, 5, 6. Okay, cool. So I have to actually adjust my color. I need to change the color of the bond between 1 and 2. Do you know what color that should be? I'll draw my hinges in to help us out. Yes, I'm seeing a lot of red in the chat. Good job. The bond between 1 and 2 is red because it was this red pair of electrons in the pi bond that swung up. And then I need to make the green pi bond somewhere. What atoms should the green pi bond be between? Should the green pi bond be between like 2 and 3, 3 and 4, 4 and 5? 3 and 4. Boom, we got it. Just swing down like this. Got it. Okay, now what other bond do I have to, or what? Yeah, I have to erase in a bond and make it blue, huh? Which atom do I have to erase a bond between to make it blue? Yeah, good job. Got to make this one blue. There we go. So the Diels-Alder reaction, we're going to learn about this later too. It's a nice one because it makes 6-membered rings, which is very important. And it's kind of cool how it goes from 3 alkenes to just 1, but then you gain a couple new sigma bonds, single bonds. Okay, Oh, actually, you know what? I should do one more. I should do a radical mechanism. Okay. These, so far what we've been looking at, they're referred to as polar mechanisms. And polar mechanisms involve pairs of electrons. So these have all been polar ones. Now, let's see a radical. And a radical mechanism and a radical mechanism involves lone electrons, not pairs. Okay, here we go. Oh, I should color code this one too. Okay, I will. So this one, I'm gonna draw the bond between bromine with two different colors. So it's just a pair of electrons, but I'm gonna represent it like with blue and green like that. Maybe that's not the best choice. Do I have a better choice for that? Would blue and yellow look better? Let's see. Not the same. Oh well. Okay, so what I have here is a carbon radical. Carbon radical because it has an unpaired electron. And while we're at it, today was going to be our secret hydrogens quiz. So with that in mind, we should be able to tell me how many hydrogens are on that carbon. How many hydrogens does that have? It has zero charge because it doesn't have a plus or a minus by it. So it's zero charge. So if I have, what do I got there? 2, 1, 3. Let's see. I'm going to draw out. I see a couple people saying 2. Let's try 2. So if I draw in 2 and I put the radical there, then the formal charge for that carbon would be group 4 minus 4 bonds minus 1 electron minus 1. Is that correct? Do we see a minus 1 by this? Nah, yeah, it shouldn't be 2. Not 2, it's 1. If you put 1 hydrogen there, then you get a formal charge of 0. Okay, so we got 1 hydrogen there. And also, for those of you, we did hear a little bit about the octet. This breaks the octet as well, because it has 2, 4, 6, 8, and then the radical makes it 9, breaks the octet. Okay, so let's see the curved arrow mechanism for this. So I'm not dealing with full electrons. Like, let me do a quick review here. I'm not dealing with pairs of electrons. So a pair of electron, we go like that. And then a radical, when it's a single electron, you do the half arrow. I had some students a few years back, they like to do this, and you could do it if you want. They would go like this. They'd show like connecting like that, like both pairs. It's up to you if you want. The radical one, you don't have to do that. Okay, so what happens with these is the radical electron is going to reach out and it's going to meet halfway between the two molecules, or approximately. And then this blue electron, which is going to hinge on the bromine on the left, is going to reach over. Oh, and I didn't touch them, did I? Be super good about this. It's going to reach over and make a bond. Boom. With the red one. And then the yellow bond is going to break off and become a lone electron on the bromine. So let's see what our product looks like. I'm going to have a bromine attached here. What color should I make the bond between this bromine and the carbon? What color are colors? It's going to be partly red because the carbon had a red electron, and partly what other color? Yep, red and blue. There we go. And then I'm going to make a bromine atom as well here. Let me shrink this guy down a bit. I'm also going to make a bromine atom here. And it's going to have a yellow radical on it. Does that make sense? Yeah, I had a question about the quiz for this. So our curved arrow quiz, I do want you to do it in color. So here's, for example, here's the answer key to the quiz you'll take. So you can see we'll have like this lone pair on the hydroxide is going to deprotonate this, which is called benzoic acid, a carboxylic acid. And then we get that. So you're going to be adding, if this is red, you're adding red. If that's blue, you add blue. So what I'll do is I'll ask you guys to bring colored pens and pencils. And if you don't, I have some you can borrow. It's no big deal. Or we can also use like, if we have like a black pen, a red pen, and a pencil, got 3 colors, just have colors that match. And so then you'll see like, oh, this one, that lone pair, you're going to fill in the products with the correct colors. On this one, the lone pair there. And then this one's another acid base one, blah, blah, blah. Then we've got these ones. That was a little more complicated. And then, so let's go back now and look at this guy. So this bromine here, I'll make this real clear. This bromine had 3 lone pairs of electrons, 3, right? It still has those 3 black lone pairs. They didn't change. The only thing that changed about this bromine is the bond that was bonded. It was bonded to another bromine, and one of the electrons of it became an electron on the bromine. So there it is. So that radical electron came from the bond. The bond has 2 electrons. One's going to go over and make a new bond, and one's going to become a lone pair there. And then does a formal charge make sense on this guy for the bromine here? Yeah, because it's group 7 minus 7 electrons and 0 bonds. So 7 minus 7, 0. All right, so we have gotten through curved arrows. Well, we've introduced curved arrows. We're going to actually do a lot more with curved arrows. And we'll pick up, I'll stop now for today. We'll pick up here. We'll pick up here next month. It'll be Wednesday, the 1st of September. Good work today. A lot of learning going on. And then those of you in the Monday, Wednesday lab, I'll see you in lab in time's now about an hour. And Tuesday, Thursday, people, hopefully I'll meet you tomorrow in person. If we can't meet in person tomorrow because of smoker, who knows nowadays, flooding, pandemic, whatever. If we can't meet tomorrow, I'll set up a Zoom as well for that lab section. Hopefully we can meet that.